add a UV sphere, and on the overlays, turn on face orientation. Create a new node group. I will name it black normals. First of all, let's randomize the orientation of the faces by flipping them with a random value. To fix this, we normally go in edit mode under the mesh menu, and under the normals, we click on recalculate outside. Let's bring back the node group we made. And now let's create a new node group to recalculate the normals. I will name this fixed normals. I have found two methods of recalculating normals. Each method has its advantage and disadvantage, which will lead us to making the third method, which combines both methods. The first method uses the center of each mesh island to recalculate which face is facing inside or outside. Let's duplicate the UV sphere a couple of times to have more mesh islands. Let's find the center of each island. Add a position node, connect it to an accumulate field node, connect the island index to the group ID. Duplicate the accumulate field node, set the value type to integer, connect the island index to the group ID. Divide the total sum of points positions on each island by the total number of points on each island. The output is the center of each mesh island. Now let's find the vectors from the center to each face position. We can do that by subtracting the position of each face from the center position. Now let's check if the output vector is pointing the same direction of the face normals. Calculate the dot product of the vector we found and the normals vector. Add a flip faces node and connect the output from the dot product vector math to the selection. This method works, but only with simple geometry. If we use it on complex geometry, we fail to fix some faces facing inside, which leads us to the second method, which uses the UV map. First, we are going to unwrap our mesh by splitting the edges, add a set position node, connect the UV map attribute to the position socket, and the mesh will be flat like the UV map. All the faces are supposed to face up if all the normals were facing outside of the mesh before the transformation. So let's flip the faces facing down by calculating the dot product of the normals and a vector pointing down, which is a vector having 0 on x and y axis and -1 on the z axis. Connect the output to the selection, and we are able to flip only those facing down. Now let's transform the points back to their original position using a set position node. Capture their position before the geometry is transformed and the face orientation is fixed. This method also has a problem. We cannot use it on geometry with no UV map. For example, this primitive cube in Geometrynos. So to solve this problem, we need to generate a new UV map using the UV unwrap node. If we connect it directly to the set position node, it will not work. We need to capture it before the split edges node. The UV unwrap node works but not with simple regular mesh, and it doesn't always make faces face up for each island. Let's add a switch node to choose between the original UV map or to generate a new one using the UV map unwrap node. Now let's combine the two methods we just made. After combining the two methods, the face normals are fixed, all the faces are facing outside the mesh, and it is using the UV unwrap node. It works even with the mesh with no UV maps now. Now we'll use the main switch node and switch nodes to be able to choose which method to use, whether to use the island center or to use the UV map, or to use both. I recommend using the method which combines all the two and also uses the UV unwrap node. This is because all the problems we have found in the two methods are fixed if we use it this way.